Welcome to June 16th LeetCode Challenge. Generate parentheses. Given n pairs of parentheses, write a function to generate all the combinations of well-formed parentheses. So here's an example here. We have n equals to 3. We want to know that we have 3 layers of parentheses to go about forming it. So then, therefore, we have 2, 3, 4, 5. So we know that we have 3 different layers of parentheses we're making, and notice how it says well formed. That means the parentheses have to have closure, right? So we need to know that every starting parentheses will have a ending parentheses that has a closure to it as well. So they have to make have a starting parentheses and a closing parentheses that are well formed, so that there are contained whatever the contents inside them would be. So you can approach this using brute force, but it's probably not the best idea because there's a lot of permutations go into doing that. I'm going to use a kind of like a backtracking algorithm to solve this, and there's other ways of doing this as well, but this is my first kind of instinct or intuition. So let's start with an opening bracket so that we can start adding things afterwards if we need it, in order to not extend the number of opening brackets. So in order to do this, we'll have an output, which is our array, right? Because we return everything with all these strings within an array. So I'm not sure what type of searching algorithm this is in general, or like what type of branching algorithm this is, but I know it is backtracking. Yes, so we have a backtracking like algorithm inside. So what I'm going to do is I'm going to define a backtrack definition. Backtrack. So what do we want to backtrack with? So we need to know the string that we're developing. So let's call this S, the string, and we want to. Oops. The next thing we want to do is we want to know the elements on the left side. So it would be an integer, so left. Oh no, right. Let's see. Actually, yes. Then right. So we want to know elements on the left and elements on the right. So the first thing we want to do, if the length of the string, is equal to 2 times the number of the integers given. So we want to know the it'd be 2 to the power of n, right? If that's the length of the string. What we want to do is we want to append our output. Append. Let's see. Append. What do we want to append? We want to append a space. No, not space. You want to join it with the character, the string that we already have. Then we want to return. What else do we need to do? If, so you want to check the left side now. If left is less than the numbers of integers we have, then what we want to do is we want to append to S, the string we have, a open bracket, open parentheses I should say. And then we want to run our backtracking algorithm again with S, left incremented 1, and then right. And then here's our backtracking step. If that's, we want to be able to pop as well from the first pop, right, from our ending. That's how we backtrack. All right, next thing we want to do. What do we want to do next? So do left. Now we want to do the right side. So if right side is less than our left side, then we want to append our ending closing bracket. Then backtrack again. This time we're appending S, left. However, right is right plus 1 now. Then we also want to pop our previous existing, our beginning. So what do we want to run here in our main code? So you want to run backtrack at an empty string Yeah, empty one, and then we want to run 0 and 0. Then we want to return our output. Let's see if this works. Yeah, it seems about the same. Let's see, show difference, there's none, submit. Alright, accepted. So what we did there was we made an empty output assigned to our array. Then we defined a backtracking algorithm, which searches through each permutations of being able to add an open bracket towards an end bracket, parentheses, just to say. And then we just loop through each. So first we defined an empty string, and we put that into our empty output. And then if the left side integer is less than our integer that we input, then we want to use append to it. And then we also want to do the backtrack algorithm, then we pop it off from the end. Because we don't want to, after we add it on, if it doesn't work, then we want to pop it off. Same thing with the right side as well. So we want the right side to be less than our left side. And then we want to call our backtrack algorithm and then return the output. So time complexity and space complexities are the same. It's actually quite complicated. There's a lot of math that goes into solving this because we are doing a what's called a, how do I say it? It's using like a Catalan's number, so it's a counting number that goes towards an algorithmic asymptote. So there's a lot of if you want to get nitty-gritty about it, but it's something that you probably can't analyze just by looking at the code here, because we only enter our definition here, only certain conditions here. So we have a bunch of if statements, so it makes the time complexity, space complexity a bit difficult to calculate. But otherwise, that's it for today. Have a nice day.